Question 8 in exercise 3C. A projectile is fired from a point on a horizontal plane with initial speed 35 meters a second at an angle A to the plane. Show that if x and y are the horizontal and vertical distances of the particle from P, then this expression 250y, so that's my displacement in y, is equal to 250 tan x. So my displacement in x, and I have displacement in x to be squared. So this is hard to see exactly where it's going at the beginning, but if we write our initial vector, it's equal to 35 cos alpha in the I direction plus 35 sine alpha in the j direction, and we set up our f of x and u of x. Displacement in x is ut, which is equal to 35 cos alpha times t. So we don't have anything to do with time here or the displacement, so we're going to have to put t into this equation. Displacement in y is ut plus a half at squared, which is equal to 35 sine alpha times t minus 4.9, just 4.9 t squared. Now will I put this as 4.9? I think I will leave it as 4.9 for now. Okay, let's put these values into this equation. So we're going to get 250 times the displacement in y. So that 250 will multiply by the 4.9 and should get rid of the decimal. So 35 sine alpha times t minus 4.9 t squared. That would have to be equal to 250 tan A times 35 cos alpha times t. And then I'm going to have minus 1 plus tan squared A times x squared, displacement in x squared, 35 cos alpha times t to be squared. Okay, we're going to have a t squared, we're going to have t, so we definitely should be able to simplify this down. Okay, it needs a calculator here. 250 by 35 is 8750. And that's sine alpha times t. Minus 250 by 5, 1250, and we're going to have to take away 1% of that. So we're going to be looking at 1225 t squared. 1225 t squared. That's equal to 250 by 35 again. So we're going to have 8750. That will be tan alpha cos alpha times t. And then we're going to have minus 1 times 35 cos alpha times t to be squared. I think it might be easier to change this one. We can see there's no tan on the left, so I think I need to change this 1 plus tan squared to, we know that's equal to 1 over cos squared from our tables, and that's going to be multiplied by 1225 is 35 35s cos squared alpha t squared, and my cos squared will actually cancel here now, so I'm missing a bracket, one extra bracket. So this should simplify to be minus 1225 t squared. We can see actually we have that on the left, and this cos alpha, tan is sine over cos, tan a cos a is going to be sine a over cos a by cos a. So we can see that tan a cos a becomes sine a. So we're going to have 8750 sine a times t, and I'm a little bit down here, so it's the left equal to the right. It is at this point. 8750 sine alpha times t minus 1225 t squared. So this guy is equal to this lopsided guy. So quad erat demonstrandum, we have proved what we've been asked to show. Part B, we're told the projectile strikes a small target whose horizontal and vertical distances are 40 and 20. Find two values for tan A and the time taken to reach the target in each case. Okay, if we go back and write the formula from the beginning, it was 250y is equal to 250 tan A minus 1 plus tan squared A times x squared, and we fill our values in here. We have my 20 and my 40, so y is first and then x, so 250 by 20 is 5,000. That's equal to 250 tan A, so we form a quadratic here, minus 1 plus tan, oh, I'm missing an x there, and I forgot to put my 40 in here, 250 tan A times x minus 1 plus tan squared A by x squared. So 250 by 40 is 10,000. So 10,000 tan A minus 1 plus tan squared A. You could do this in one step if you wanted. By 40 squared is 1600. So we're going to get, well, I won't try and simplify it too quick. 5,000 is equal to 10,000 tan A minus 1 by 1600, so minus 1600, and minus tan squared A by 1600 minus 1600 tan squared A. So tidying this up, I can definitely knock 2 zeros off to begin with. Divide by 100 for everything. So I'm going to have 16 tan squared A. I have just 1 tan A, I have 100 tan A, and I'm bringing it left, minus 100 tan A. So I counted for this one and this one, not leave anything behind. And then I'm bringing 50, I have 50 there already, and I'm bringing a 16 across, so plus 66 is equal to 0. And it definitely divides by 2. 8 tan squared A, that'll give me a 33, which I don't think we can divide anything into. 8 tan squared A minus 50 tan A plus 33 is equal to 0. So what have we got here? It looks like 8 by 1 or 4. I'll try 4 by if you want to change it to x, you can. 8x squared minus 50x plus 33 equals 0. Some people prefer this. I'm going to try the 4x by the 2x first. If that doesn't work, I can go to my 8x by x. 11 and 3 has to be 11 and 3 here, doesn't it? Yeah, 44 and 6. 11 and 3 will give me the minus 50. So tan A is equal to 3 over 4, or 11 over 2. So to get my, I'm looking for my times, how many so I'm going to need to get it in terms of, can we ask for the angles? No, two values for tan A and the times, so we're not even asked for the angles here. So if I just create my right angle triangle so I can get cos A, opposite, adjacent, hypotenuse, so I've got cos A is 4 over 5 in this triangle, and the second one 11 over 2 opposite over adjacent, which is going to leave the square root of 121 plus 4, which is root 125, 121 and 4. So cos A in this triangle is 2 over root 125. So in both of these cases, the displacement in x was 40. Was it 40? 40. Displacement in x is 40, and that's equal to u cos alpha times t. So we had 35 cos alpha times t is equal to 4 over 5. So 35, not 4 over 5, 40, I'm thinking of the cos of the angle, 40. So we have 35 by 4 over 5 times t equals 40. So that's going to be t is equal to 5 40s, which is 200, divided by 35 fours, which is 140. So 20 over 14 is going to be 10 over 7 seconds. And in the second one, s of x is equal to 35 by 4 over 5 times t, no, not using the same ratio, times 2 over root 125 times t is equal to 40 again. So I'm going to get t is equal to 40 by root 125 divided by 35 times 2 is 70. So I'm going to get 4. And we asked for a decimal in this case, so it just works out evenly. What do we ask for? The time taken. I'm just going to type this into a calculator here. The time taken in this case is 6.38 seconds for this one. Don't think it simplifies down any further. We 4 over 7 times the square root of 125, which is root 25, which is 5 by root 5. So 20 root 5 over 7. I don't think simplifies down any further than that. So 6.38 is probably the best form to write this time in. So that's question 8, quite a long one. So let's move on to question 9. Question 9. A particle is projected from the ground with a velocity of 50.96 meters per second at an angle inverse tan of 5 over 12 to the horizontal. Let me just jot that down real quick. Opposite over adjacent, hypotenuse, cos A 12 over 13, sin A 5 over 13. On its upward path, it just passes over a wall 14.7 meters high. During the flight, it also passes over a wall 18.37 meters high. Show that the second wall must not be less than 23.52 meters and not more than 70.56 meters from the first wall. Okay, there's a lot in this question, so let's start off with what we know. We can do our initial velocity vector. It's going to be u cos alpha times I, or in the I direction, plus u sine alpha in the j direction. So u 50.96. So a lot of decimals in this question. 50.96 times, does it divide by 13 for us? 12 over 13 in the I direction, plus 50.96 by 5 over 13 in the j direction. These work out to be decimals. I thought they might be whole numbers, but they work out to be decimals of 47.04 plus 19.6 in the j direction. So this is my initial velocity vector. Now a diagram is going to be important. Okay, let's sketch a diagram. On its upward path, it just passes over a wall 14.7 meters. Right, well, we know the diagrams are all the same shape. So here's my projectile. So on its upper path, let's say here, it just passes over a wall 14.7 meters high. So we'll call this one 14.7. And then somewhere along the journey, it also passes over a wall 18.375 meters high. Let's say it's here. 18.375. So it is hard to see where this question is going. So just fill in your information and do what we've done on all of these questions. So we can see here, this is s of y. This is s of y. If we could find this distance here, it might help us. So let's have a look at, see, can we get the time maybe to get to this point of when it's at 14.7. So we know s of y is equal to ut plus a half at squared. So you can see here, we're definitely going to be able to get time because we have the initial velocity in the j direction and we have a. We don't know t, but we do have that this is equal to 14.7. Now there is going to be another time. Let me change colors here. There's another time when it's going to be 14.7, which is on the way down. So we should get 2 times here. So what have we got? 19.6t minus 4.9t squared minus 14.7 equals 0. 4.9t squared. Actually, 4.9 goes into 14.7 and 19.6, so this will work out easy for us. 4.9t squared minus 19.6t plus 14.7 equals 0. So I've got 4.9 in there, I've got 4 of them in there, and I've got 3 of them in there. So okay, that's why these vectors worked out to be decimals. They do divide by 4.9. So we have t minus 3 by t minus 1, quite obviously here. So if t is equal to 3 and t is equal to 1. Okay, so here's my t is equal to 3 and here's my t is equal to 1. So that will help me definitely get my displacement in x. So along here, my s of x at t equal to 1. So s of x at t equals 1 is equal to ut. So it's just going to be 47.04 here, isn't it? T is equal to 1, so I've got 47.04 times 1, which is 47.04 meters. So that's that distance and that distance there. Now we're on to the second wall. Let's say it's here and here. This wall is 18.375. So we should be able to get 2 times, which will enable me to get this one here. So yeah, we can just let s of y equal 18.375. So 19.6 t s of y equals 18.375. So 19.6 t minus 4.9 t squared minus 18.375 equals 0. Just copying this equation here without having to write the whole thing out again. So we're going to get 4.9 t squared minus 19.6 t plus 18.375 equals 0. Now does 4.9 go into 18.375? My calculator is telling me it does go in, but it's a fraction. So I've got t squared minus 4t, dividing them all by 4.9. And it's giving me 15 over 4 for this. Equals 0. So I'm going to multiply them all by 4. 4t squared minus 16t plus 15 is equal to 0. It won't change to times for me. So is it 4t or is it 2t by 2t? I'll try the middle one first. 2t by 2t. Is it 5 and 3? Yes. 10 and 6 gives me my minus 16. So t is equal to 3 over 2 or 5 over 2. Right, let's have a look here. If t equal to 1, I have 3 over 2, I have 5 over 2, and we can see the symmetry here. The difference between the values is half a second. So if I get displacement in x when t is equal to 3 over 2, I can find this total distance, and then I can just take this distance away and see what we get. Hopefully it relates back to the question. So s of x at t is equal to 3 over 2 is going to be 47. Just copying the same equation, you could write ut 47.04 by 3 over 2 or 1.5. So adding half of 47.04 onto itself, I'm going to get 70.56. I'm adding 23.52 on. That's right, 23.52 and 47 is 70.56. Okay, let's jump back up to this question here. I'm going to just rewrite this 70.56 so you can actually see it. Right, what are they asking us? Show that the second wall must be not less than 23.52 and no more than this. Okay, this 23.52. Well, that is actually we're working that out in our heads here. That's the difference between 70.56 minus 47.04 is 23.52. So that's that distance there, 23.52. What are we asked to show? And not more than 70.56 from the first one, so less and more. So we're looking at both of these here. So just try and keep the diagram for a second. So we need, going green here, we need this distance up to t is equal to 5 over 2. And then we'll have the distance between here and here, so that the max and the min really is what this question is. So when t is equal to 5 over 2, s of x at t is equal to 2.5 is equal to ut, which is 47.04 doubled with half added on, 47.04, 94.08 plus your 23.52 is going to give me 117.6. I'll just double check this, 117.6. So if we take away 47.04 from that, we are going to get 70.56 meters. Is that what they asked for? Thank God they asked for 70.56 meters. So in a question like this, one simple step at a time, read the question carefully, do a diagram to help you. It's gotten a little bit messy here, but with the colors, hopefully you can see what's going on. And that's question 9 completed. So we'll go on and do question 10 in this video as well. Question 10 is 3 parts. We'll look at the first part. Initially, a ball is kicked from point P on level ground. It hits the ground for the first time 27 meters from P. So this is my 27, my displacement in X. And we're told that that's after 3 seconds. So T is equal to 3 when S of X is equal to 27. That's the information they've given us here. And again, there's going to be a vertical wall here, 5.4 meters from P. We'll put it here for now. So let's look at our initial vector. Is equal to U cos alpha times I. And we haven't been given U or alpha here. So plus U sine alpha times J. We have been given S of X. S of X is equal to UT, which is equal to 27. So my U is U cos alpha times T equals 27, and I have T is equal to 3, so 3U cos alpha is equal to 27. So U cos alpha is the horizontal component. That's equal to 27 divided by 3, which is 9. So well, we also know at this point my vertical displacement 0. So let's have a look here. S of Y is equal to U sine alpha, UT minus 4.9 T squared. That's going to be 0. So U sine alpha times T, which is 3, minus 4.9 by 3 squared equals 0. So 3U sine alpha is equal to 9 4.9s, which is 44.1. 45 minus 0.9. And then we have U sine alpha is equal to 44.1 divided by 3, which is 14.7, I think, 14.7. So that's my vertical. So I have my U cos alpha 9 in the I direction plus 14.7 in the J direction. In part 2, we're asked to find the height of the wall. So we're asked to find this here, the height of this wall, the displacement in Y. What else are we told? Well, here's P where it's kicked from. So we know S of X is 5.4. So what else do we know about S of X? We know that the displacement in X is equal to U times T. We've got our U, so 9T is equal to 5.4. So T is equal to 5.4 over 9. 9 sixes are 54, so T is equal to 0.6. So what we need to do is we need to put this 0.6 into displacement in Y, and we get the height of the wall. UT minus 4.9 T squared. So 14.7 by 0.6 minus 4.9 by 0.6 to be squared. And I'm just going to type this into a calculator. It comes up as 3 decimals. 7.056 meters is the height of the wall. So the speed of the ball is part 3 as it passes over the wall. So we need our V's, our velocity in X. It's not going to change. It's going to be 9. And V of Y is equal to U plus AT, which is 14.7. minus 9.8 times time, which is 0.6. And that's going to give me 8.82. So my vector, as it passes over the wall, is 9I, or V, plus 8.82 in the J direction. So the magnitude, I'm going to change this to a V, the magnitude of this vector is the square root of 9 squared plus 8.82 to be squared, which is equal to 12.6 meters per second. So we'll leave that video with question 10. The next video will have 11 to 14.